Let's briefly go through this paper with Scholaread, Retentive Network, a successor to Transformer for large language models. Retentive Network, RetNet, is a new architecture for large language models that achieves training parallelism, low-cost inference, and good performance. The retention mechanism for sequence modeling supports three computation paradigms, that is parallel, recurrent, and chunkwise recurrent, which enable efficient long-sequence modeling with linear complexity. RetNet is a strong successor to Transformer for large language models. The authors of the paper argue that the current state-of-the-art language models, such as GPT-3, suffer from several limitations, including high computational cost, slow inference, and poor scalability. To address these issues, they propose RetNet, which is designed to be more efficient and scalable than existing models. RetNet is based on a retention mechanism that allows the model to retain information from previous time steps, which is critical for modeling long sequences. The retention mechanism is implemented using a set of gates that control the flow of information between different parts of the model. The gates are trained using a novel objective function that encourages the model to retain information that is relevant to the task at hand. Reading on mobile can be a disaster. But Scholaread app is here to help. Get Scholaread on App Store or Google Play and read smoothly at your fingertips. RetNet supports three computation paradigms: parallel, recurrent, and chunkwise recurrent. The parallel paradigm allows the model to process multiple sequences in parallel, which is critical for efficient training on large datasets. The recurrent paradigm allows the model to retain information from previous time steps, which is critical for modeling long sequences. The chunkwise recurrent paradigm allows the model to process long sequences in chunks, which is critical for efficient inference on long sequences. The authors evaluate RetNet on several benchmark datasets, including the Lambda language modeling dataset, the Wikitext 103 language modeling dataset, and the GLUE benchmark. They compare RetNet to several state-of-the-art models, including GPT-3, and show that RetNet achieves comparable or better performance while being more efficient and scalable. The authors also evaluate RetNet on several downstream tasks, including sentiment analysis, question answering, and natural language inference. They show that RetNet achieves state-of-the-art performance on these tasks while being more efficient and scalable than existing models. Overall, the authors argue that RetNet is a strong successor to Transformer for large language models. They show that RetNet achieves comparable or better performance while being more efficient and scalable than existing models. They also provide a detailed analysis of the retention mechanism and the three computation paradigms, which provides insights into how RetNet works and how it can be further improved in future work. The authors suggest several directions for future work, including scaling up RetNet in terms of model size and training steps, using RetNet as the backbone architecture to train multimodal large language models, and deploying RetNet models on various edge devices, such as mobile phones. They also suggest that retention can efficiently work with structured prompting by compressing long-term memory, which could further improve the efficiency and scalability of RetNet. In conclusion, the paper presents RetNet as a new architecture for large language models that achieves training parallelism, low-cost inference, and good performance. The retention mechanism for sequence modeling supports three computation paradigms, that is parallel, recurrent, and chunkwise recurrent, which enable efficient long-sequence modeling with linear complexity. RetNet is a strong successor to Transformer for large language models, and the authors provide experimental results that demonstrate its favorable scaling results, parallel training, low-cost deployment, and efficient inference. The authors also suggest several directions for future work, which could further improve the efficiency and scalability of RetNet. That's it for today. For a seamless reading experience, download Scholaread. Stay curious. And don't forget to like and subscribe to my channel and press the bell icon to get new video updates.